All right. Hello, everyone. We are welcome to the science class. This is lesson 31 on minerals and precious stones. So we have already talked about some of these principles. So we are going to go into a little bit more detail here in the class today. Okay. So in a previous class, we talked about this concept that minerals are the building blocks of rocks. But actually, when we look at what is the definition of minerals, okay, so I have here a link to the Wikipedia article for minerals. It actually it gives us some very interesting information, okay, about the minerals. It says that it's a naturally occurring substance that is solid and inorganic, representable by a chemical formula, okay. Usually it says it's abiogenic. That means that it's not by an organic, a biological genetic process, okay. So minerals are different from some of the carbon-based structures and so on that we create as a biological entity. So that's the difference between that. It also says that it has a Nordic atomic structure. Okay. The difference between mineral and a rock is that rocks are usually aggregates of minerals or non-minerals. Okay, and so when we are talking about specific concentration of this specific chemical structure, then we are talking about a mineral. And there are over 4,900 known minerals. So that is amazing, really, the amount of, the number of minerals that are there. Okay, so further down in the article, it gives here the basic definition of a mineral, and it is 5 characteristics. Okay, one is naturally occurring. It is stable at room temperature, represented by a chemical formula. Okay, usually abiogenic. So not resulting from the activity of living organisms, okay, and its order atomic arrangement, okay. So Jens asked, I wonder if there are minerals that haven't been discovered, okay. I imagine, I imagine that there probably could be still minerals to be discovered. Okay, so there is an organization here, the International Mineralogical Association, that is basically in charge of looking at all the minerals and finding them, defining them, and so on. Okay, so the article here says also that there's a specific type of minerals, silicate minerals, that compose over 90% of the Earth's crust. Okay, so silicate minerals are the minerals that are based on silicate. Okay, silicate is a specific type of mineral. We are going to talk about that in more detail. We already did before, but we'll review that, especially because it's so important, so prevalent. About 90% of the Earth's crust is composed of variations of this silicate mineral. Okay, very, very abundant. Then the article here talks about how minerals can be described. So they are chemical compositions. So you can describe the mineral by its chemical composition. And also, you can describe the mineral by the physical properties of that mineral. And the properties of the mineral are the crystal structure and habit, The habit is also kind of another way of talking about how is the crystal structure of that mineral, how hard it is, the hardness of the mineral. Luster is whether it reflects light or not. Okay, so some minerals have more, they are more shiny. Okay, they have a higher luster, and others are opaque, and they don't reflect light, so they have a low luster. Diaphaneity, if I pronounce that word correctly, that refers to how transparent they are, whether they are transparent or not. Okay. The color, okay, of course, which color they are, and that depends on the minerals that are composed, the atoms that are composed, and what type of light they reflect. Okay. Streak is another characteristic. Tenacity and cleavage. Cleavage is how they break. Okay, whether they break in a specific shape or not. Okay, and then that also includes fracture and parting, and then the specific gravity, how heavy they are, how heavy is that mineral. So of course that because of the chemical composition of the mineral, the specific chemical composition, what are the atoms that compose that mineral, is going to have a specific weight. Okay, and so that is what gives the specific gravity of the mineral. Rodney says there are other minerals still not discovered. Okay, so that's good. So there's still work to be done, lots of things to learn and do. So for the homework for this class, I'm going to ask you the assignment. Okay, so here we have the homework. Let me put this a little bigger. So the required homework is to write a 3-page report about a mineral of your choice. Okay, so you can choose a mineral. It could be any of the ones that we discussed here in class, or another one, gold, carbon, whatever mineral you choose, and then write a report of that. And you need to include information about the chemical of the mineral, where it is found, the physical properties, how it is used. You can include pictures, okay, of that mineral, crystals, and so on, and other things, okay, whatever else you want to do, but that is kind of the required. Steel is not a mineral. Steel is a compound because it's actually an alloy. It's like an alloy of iron, the mineral iron, and carbon. So when you mix those things, that is what is the definition for an alloy, and steel is an alloy. Salt is a mineral, okay? The mineral name for salt is halite, okay? So there is there's that, all right? Emma says, can't wait to get started. Excellent. Yeah, so let me go here. Let's see. I have a little video. This is a very interesting video that I think in person, kind of a review of some of the minerals, and see how this professor, this is from a university, and it talks about how to identify minerals. So it's actually looking at the physical properties of those. Okay, can you hear okay?
barite. Barite, right? Very, very, very thin. It's bauxite. Bauxite. It's bauxite. It kind of looks bauxite. Nowadays, a lot of times when it's colored like this, a lot of times that's however, it's also Bornite. And probably Bornite as well.
So it just goes through, you know, the different minerals here, okay? All right. And I want you to, okay. It sounded really fuzzy, the sound, sorry about that. All right. You can look at, I'm not going to go through the whole video because he has a lot of, a huge gallery of the different minerals. But before you choose which mineral to study in for your assignment, okay, look at this video and see how he describes the different minerals that are there, okay. This is another video. It doesn't have any audio, I believe, okay. It's just kind of a photo gallery. Oh no, it actually has a narration. The professor doing this is actually describing how he takes the photographs, the photography for these minerals. Sometimes he uses a microscope and so on. But really beautiful, beautiful photographs of the different minerals. And here the pictures, you see that some look very delicate in their crystal structure, how the crystals grow. Here, this one, the garnet, is actually this red one. The other one is mica. Okay, and you see that sometimes minerals are embedded into other minerals to form very, very beautiful, beautiful specimens. Okay, so again, you can look at more of the video. When you see the video, you know, when I share it here online, it is difficult to see everything. So during the video, I was imagining a high-pitched nasally voice saying the exact mineral content of every single type of rock. Okay. Not interesting. Yeah, so I imagine that the transmission of video and audio makes one of them kind of choppy. But that is why I include these links in the lesson to the videos, so you can actually, after the lesson, you can look at the videos, watch the videos, and see them better. Okay. So let me see. Here we have, I did a quick look at minerals images in Google, and we have lots of different pictures. Okay, sometimes most of them are unidentified minerals, but you see okay, having over, you know, close to 5,000 types of minerals. You can see that there's probably a lot to see on that. Okay, so let's talk a little bit about let me see here what we have. Okay, so here we have the picture of granite. And remember that when we were talking about granite, we said that this igneous rock that cools down is a plutonic igneous rock and cools down slowly. And as it cools down, the minerals within the lava, the magma there, they form into crystals, okay? So the crystals are what gives kind of the different structure here to the granite. All right. Natasha asked, are the crystals in geodes minerals? And Sabrina said, yes, that's correct. Yes. So most crystals are forms of a specific mineral. In next week, the lesson is going to be on crystals. So we are going to talk all about crystals. And I'm hoping to see if I can arrange for Rodney's father to join us to class. Okay, we'll talk more about that, Rodney, after class. Yeah. So Natasha says, I have lots of minerals then. Great. Excellent. So take pictures of them and share them with the class, okay? I would love to see the pictures of the crystals and minerals that you have. Is it a ruby, a mineral, or is it many minerals? Okay, let's search that out. All right, you can search it while I keep talking. Okay, I believe that it is a particular mineral. Gold is a mineral, and here you see an image of a rock containing gold. That is, the gold is actually kind of embedded within another rock, form of course, other minerals. That rock crystallizes into, and clumps together, then you can actually mine it that way. There's a lot of gold that is dispersed, if you wish, in just rocks, okay? Here I did my daughter did a science fair project, okay, where she studied the composition of sandstone, all right? And so she got several samples of sandstone from different places. And my bishop, that is a chemical engineer, he basically did a spectrometrical analysis of the sandstone to identify what are the different elements, what are the minerals that compose that sandstone. And one of the samples indicated that had quite a bit of gold, okay? So the other sample had some gold, but not much. So there are people that mine gold also that way, that basically samples and then they take the gold out of that soil. Okay. All right. So Sabrina says it's a mineral, probably referring to ruby. Most precious and semi-precious stones are natural. So Sabrina found a super small ruby one. It was in our granite countertop. Wow! So your granite countertop came with a precious stone. That is awesome, really. Did you take it out? Did you take the ruby out, or do you leave it there with the countertop? I imagine that you probably don't want to cook over that or kind of protect it. Have a little image also of some precious stones of different colors, okay, different minerals provide a different shape, cells and everything. You left it there in the counter. I'd love to see that countertop. Here we have also a picture of a geode, okay, we talk a lot about that. Jen asked, what makes them colored? What do you think that makes them of different colors? What makes the minerals, and the precious stones different colors? The chemicals, yes, it's the chemicals that are in there. So it is really, Sabrina says pigments. Well, pigments is also chemicals, all right, is the minerals that are in there. And they all basically, when you think about it, when you go to the bottom really of it, the idea is that the atomic structure of the mineral reflects a different wavelength of light, and that is what gives things its color. Okay, so things have different colors because of the type of light that they reflect. All right, and so that the atomic structure, the chemical composition of the mineral is what gives it the specific color. All right. Annika says, half of my middle name is Ruby. What is your middle name, Annika? Annika says, a ruby is a pink to blood red color gemstone variety of the mineral corundum, aluminum oxide. The red color is caused mostly by the presence of the element chromium. Okay, so that is probably this is a ruby. Okay. All right. Excellent. Good deal. Very, very pretty stones. Here we have a picture of diamonds. And diamond is also a mineral. It's a specific form of the crystalline structure of the mineral carbon. So it's pure carbon. And we are going to talk more about diamonds next week, hopefully. Rodney's father will help us to learn more about diamonds since he makes them. But diamonds are pure carbon that are that they were formed basically under a lot of pressure and heat. And so the atomic structure of the carbon shapes in a kind of a cubic shape, okay? And that is what makes the crystal have all these different facets and very flat faces. Interestingly enough, graphite is also pure carbon. But graphite, which is what you could find, you know, in a pencil, the lead of a pencil. The pencil doesn't have lead, actually. It has graphite mostly and other chemicals to make it harder. But graphite is pure carbon, but because it is crystallized at a lower pressure and a lower temperature, the crystals of graphite are kind of more forming in sheets, okay? And so it is more brittle and it breaks easier, very soft compared to diamonds. But diamonds is the hardest mineral that we know, okay? So it is very interesting that the formation really of the crystals and the minerals are really what gives the different colors, the hardness, the shapes of the rocks that we encounter. So Haley said, so you could turn graphite into a diamond. Yes, absolutely. Absolutely. So the idea is that as you put more pressure and temperature, okay, the graphite gets restructured, recrystallizes into a diamond. So we are going to talk more about diamonds next week. Okay. So today, we talk about what are the different characteristics of diamonds, the basic definition of them. Okay. And then here in the article, let me jump. So we have mineral chemistry, the section here, and then here, this is the section on physical properties of minerals. And it talks about the different properties. So we were talking here and the introduction, okay, of the article. It says this paragraph, it talks about the physical properties. So as we go down in the article, we see more detail on the different properties. Okay, so for example, the crystal structure, we have the different type of crystal structures. Okay, and then it talks about that hardness. Okay, talc, hardness of 1, so they are classified by different hardness, and different minerals have a number. Okay, so depending on the mineral, they would sit somewhere within this scale of hardness. Diamond being the hardest, talc being the softest. Okay, so it's interesting that talc is also a mineral. So Sabrina says coal is carbon. Okay, yes, so coal is also carbon. Sometimes coal has more impurities. Okay, so it's not just carbon. All right, and when you have large carbon deposits, if they are buried under pressure, they form a carbon mineral called andesite. Okay, that is carbon rock. It's really the carbon made into rock. If it's pure carbon, then it's graphite. And if it's pure carbon under lots of pressure and heat, it turns into diamond. Okay, so you can see all the different types of how carbon is used. All right, and of course, remember here that when we talk about minerals, one of the definition, the characteristics is that usually the minerals are abiogenic, so they are not created by living organisms. Okay, and this is says that it's usually so that a lot of organisms use carbon. Carbon is actually used a lot. All right, by organisms. We are all carbon based. Okay, and so we eat carbon and we mix carbon to form lots of different, all the structures in our body and plants and everything, they are all carbon based with other minerals to produce different structures. Okay, but we use the minerals in order to produce these compounds. So now the difference is that usually we use carbon with hydrogen and nitrogen and other things, and so our materials are organic. Okay, so does that make sense? Emma says, I have a question. So since the gem can't be abiogenic, is that one of the reasons a pearl isn't considered a mineral? Okay. Yeah, that would be the case. So the pearl, okay, is formed by a genetic, by a biological process, but so are the shells of mollusks. Okay, all the marine animals that have hard shells. Okay, they basically use minerals to create those shells and to create pearls. All right, so it's very interesting. So I don't know what is the borderline between what is considered a mineral or what is considered a biogenic compound. Okay, I really don't know, but that is where it gets kind of interesting. Yeah, Annika says, that is why you can tell how old something is by counting the carbon. The less there is, the older the object. The more there is, the younger. It's not just counting the carbon. So the carbon dating method is counting the carbon isotopes. Okay, so an isotope is the element where it has more electrons or less electrons. Okay, so isotopes. Okay, so in nature, carbon has a specific proportion of pure carbon or carbon with isotopes. All right, and so when the organic animal or plant dies, then the amount of these isotopes starts diminishing, and that is what scientists count is the amount of carbon isotopes to determine the age of the object. All right. Okay. Good deal. I said the gem couldn't be a biogenic. So, you know, why don't you search that while I keep talking? Search, okay, the question about pearls and whether pearls are considered to be gems or if they are considered to be minerals or not, okay?
Oh,
So,
I was just correcting myself because I was reading over my question again and I found out that I worded it wrong. So I was just clarifying it.
Yes, no problem. Thank you for the clarification. That's good. But these are really good questions, okay? And as you can tell, I don't have all the answers, all right? I just know what I know and I know what I don't know. Okay? But that is great, all right? So we were talking about the physical properties of the different minerals and how here in the article we have a further definition of these properties. So when you study when you do the report on your mineral, whichever mineral you choose to study, you can look and see, you know, study what are the different properties for that, okay? There are other properties for minerals like magnetism, radioactivity, you know, and so on. Okay, so very, very interesting article. It is actually quite accessible. We'll be able to understand most of it. Okay, now we are going to talk about three specific kind of minerals or compounds, something that I found very interesting. So silicon dioxide, okay, is silica. That's another name for that, but the chemical composition is silicon dioxide. So the chemical formula is Si, one atom of silicon, and two atoms of oxygen. So di meaning two, oxide, oxygen. Okay, so silica is the building block to a lot of minerals, and is based, all these minerals are based on that, okay, on silica. And so let me see what we have here. There are some examples, okay, of how silicon is used and the different compounds that it makes, the structure, okay, so you have, you know, one atom of silicon and two of oxygen joined together at a specific distance and at a specific angle. And that angle is what makes the different structures, okay, for the minerals. So when you add other things to the silicon, you are going to have a reaction and create another mineral. And so that is what here it is shown, okay? And all these minerals that are produced with silica, they are basically these mixes of silica with something else. So here, for example, it talks about the different that can happen. And one of them is how to make glass. Okay, so glass is actually made of silica. Sand is also silica. Okay, so most of the sand that you see on the beach and everywhere is just, you know, silica that is broken down. Okay. As I was reading here the article on glass, I found some really interesting things. Okay. One of the things that I found is that glass is not a crystal. Okay. As I said, in the next week we are going to talk more about crystals. But one of the characteristics of crystals is that they have a repeated pattern on the atomic structure. Okay. So, and glass is not, it doesn't have this repeated structure. It's an amorphous solid. So the molecules of glass are not in a crystalline structure. It is often transparent, but because it's amorphous, and also, okay, there's another characteristic. Sabrina says glass is a liquid, very, very dense liquid, all right? Glass is made out of sand that is heated and melted, so the sand is melted. And let's see this part. It says, of the many silica-based glasses that exist, ordinary glazing and container glass is formed from the specific type called soda lime glass. Okay, so what this is saying is that there's many ways of doing glass, okay, but the one that is used mostly for glazing and doing containers, for doing bottles and doing glass panels in windows and so on, it is what is called soda lime glass, and is composed 75% of silica, silicon dioxide, okay, 75% of that. Then it has sodium oxide. Na is sodium, all right, so 2 atoms of sodium, 1 of oxygen, and sodium carbonate, 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. Calcium oxide, okay, that is 1 atom of calcium and 1 of oxygen, also called lime, all right? So calcium oxide is lime. And so these 4 components, and then it says, and several minor additives, all right? But mainly these 4 components are what makes most of the glass that we use, okay, that we use in glazing. So sometimes they add other additives and other things in order to give it a different color or a different hardness and so on, okay? So Sabrina says glass is even more viscous than molasses. That is why people have to split the window on super old houses. That's right. So in very, very old houses, the panes of glass, actually, if you were to measure them, they are thinner at the top, and then they are thicker at the bottom. So slowly, very, very slowly, the glass actually kind of falls, falls down, because it is in a liquid state, if you wish. One of the ways that people can see how that it's liquid is because when you heat glass up, it goes from the solid, what we would call solid state, or we would see as solid, into liquid without a temperature plateau, okay? I would like to talk more about that, but I don't know that I have time. So But this is a very interesting article on glass, on the different types of glasses and how they are made and everything, and you know, the solar line silica glass. Okay, it has even more information about that and other types of glasses that are made. All right. So you could do your assignment if you wish also on glass as one of the very useful, if you wish, forms of minerals, of silica-based minerals. Okay. So I don't know if glass would be considered a mineral, would be a compound, because it is made out of several, you know, different minerals. So one of those would be that. So it says here the article that a very clear and durable quartz glass can be made from pure silica. So that would be, if you wish, a mineral. Okay, quartz glass. The other compounds, so the compounds are just mixes of minerals, are used to improve the temperature workability product. So they are made, so the compound is made so they can be worked more easily at lower temperatures, I guess. So Emma says, I have a hypothesis. So we were talking about silicon dioxide, and I read that silicon dioxide is formed by a strong directional covalent bonds and has a well-defined social structure. So if the gemstone possesses silicon dioxide or silica, would that mean that silicon dioxide might contribute to its structure and bonds? I mean, since silicon dioxide is formed, it is from some gemstones. Okay, that is right. Yes. So this is similar to if you were to play Legos. Okay, just think of these minerals with a specific structure as the building blocks of the other compounds and things that you can make. Okay, and so the silicon dioxide, the silica, has this structure. Okay, that is represented here. Okay, where you have the silica, the silicon atom in an angle, specific direction and strength with oxygen, and they are very strong in this covalent bonding that it has. And so when you mix the silicon dioxide, the silica, with other elements, you add to that a specific structure. It changes the structure, and that is why the compound will have a different color and a different composition and different properties. That is kind of the basic building block for that. Okay? So really, really interesting. Sabrina here in the chat shared the formula for glass. So you have the silicon dioxide plus the sodium oxide plus the sodium carbonate and the lime, and then it forms the glass, the formula for glass. You can see that there in the chat. Very, very good. Thank you for sharing that. And you can see that, you know, these formulas, sometimes they may be a little intimidating, okay, for you to look at and everything, but I really suggest just take it in stride, look at them carefully, you know, little by little, and you will find that they are not that difficult to understand, frankly, okay? I have a question here, and I couldn't find really the answer to this. Is water a mineral? Okay? Is water a mineral? So water, here I have the article of water. Okay, water is a transparent fluid. All right. is a chemical compound. The water molecule contains 1 oxygen and 2 hydrogen atoms, and they are connected by covalent bonds. So that is similar to silica, okay? So it has a very specific, chemical structure, all right? It says that water is a liquid at normal temperature and pressure, a solid state and gaseous state, okay? So water is, in a lot of, in all 3 states, okay? Very, very common here, okay? So water is very common on the earth, and actually has a lot of very interesting properties. So I was thinking, is water a mineral? So we see here the basic definition, okay? And it says that for a mineral, the general definition, that it has to be naturally occurring. So is water naturally occurring? Yeah, check. Is it a temperature? Yeah, it's also stable at room temperature. Is it represented by a chemical formula? Yes. It's usually abiogenic, yes. Okay. And has an order atomic arrangement. Well, that is where I'm kind of a little bit confused, if you wish, between the definition, the basic definition here of a mineral and whether water is a mineral or not, because, it has an order atomic arrangement, but at room temperature, it is a liquid. Okay, once you cool it down, then it becomes a solid. So I'm not sure whether the definition of a mineral has to be that it's solid or not. I imagine that mercury is also liquid and is also a mineral. Okay, so I would say that water is also a mineral. Okay, I don't know. That would be something that I would love to ask and find out. Okay, to me it fits all the definitions of mineral. Mm-hmm. So let's see. Riley says, Google says, water does not pass the test of being a solid, so it is not considered a mineral, although ice, which is solid, is classified as a mineral as long as it is naturally occurring. Thus, ice in an ice cube from the refrigerator is not. Okay, so it has to be naturally occurring. All right. Annika also puts water does not pass the test of being a solid, so it is not considered a mineral. All right. Ice in a snowbank is a mineral, but ice cube from a refrigerator is not. From the Mineralogical Society of America. Good deal. Excellent. So bottom line, water is confusing. Water is confusing, but I love water. I find it very, very intriguing. Okay, that's why I wanted to talk about it here, because it's not only that it's very, very prevalent, it's essential for life. Okay, so I wanted to share this article with you here. The interesting part, one of the most interesting parts for me is why does water float? Okay, do you know why ice floats? Why does ice float? All right, and it's a great blessing that ice floats, because imagine that if ice wouldn't float, when the ice would actually go and it would bury all the fishes.
So fishes and life, survives the winter because it's actually protected by the ice that is floating. Okay, so very, very interesting. So that is one of the questions. And here in this part of the article, chemical and physical properties of water, it talks about all the different properties of water, and this part kind of giving the answer of why ice floats. Okay, so I want you to look at that. I'm going to put it kind of as an extra assignment. Okay, so Madeline says the ice is less dense. The question that I have for you, Madeline, is yes, it is. That is the case, but why? Why is that ice is less dense? Because almost everything else, okay, when you cool it down, the atoms are closer together, and so it's more dense. So anything, okay, minerals, gases, liquids, everything, when it's cooled down, is more dense. Water is also more dense when it's cooled down. But why is ice less dense than water so it can float? That is the question that I'm asking. Okay, so I want you to explore that. Okay, and see and learn that issue. It's very, very interesting. So you get the question. Okay, good deal. To finish the lesson, I would like to share, kind of the application of all these things that we have been talking about, to the gospel, to one of the gospel principles. And I want to share here from the book of 1 Samuel, chapter 16, okay, and verse 7. This is kind of a classic part, all right? And the part that I want to share specifically that we are going to focus is this part of the verse. It says, "For the Lord seeth not as man seeth, for man looketh on the outward appearance, but the Lord looketh on the heart." Okay. The story is really about when Samuel was called by the Lord to find a king to replace Saul. Okay? So the Lord says to Saul, "How long will that mourn for Saul, seeing I have rejected him from reigning over Israel? Fill thine horn with oil and go. I will send thee to Jesse the Bethlehemite, for I have provided me a king among his sons." Okay? So the Lord tells Saul, go and to this house, to the house of Jesse in Bethlehem, and I'm going to tell you that one of his sons is going to be the king. Okay. And Samuel, "How can I go? If Saul hear it, he will kill me." And so the Lord tells Samuel, just go and tell that you are going to give a sacrifice, all right? That, and then go and do a sacrifice, and don't tell anyone what is it. Okay? And call the sons of Jesse to the. And so what happens is that Jesse calls his sons from oldest to youngest, and so Samuel doesn't choose any of these. The Lord doesn't choose any of the sons of Jesse. Aminadab, Shammah, okay, even 7 of his sons to pass before Samuel. Okay. And the Lord says, "The Lord hath not chosen these." And then Samuel says, are here all thy children? And Jesse says, well, the youngest one, okay, the youngest one is looking after the sheep. And so Samuel says, go and send for him. And so Samuel brings him and says he was ruddy and of a beautiful countenance and goodly to look to. And the Lord said, arise, anoint him, for this is he. And this is David. This is King David. Okay. So the Lord sees us in a different light as how we see ourselves. And it is really similar to how we can look at rocks, you know, and not see the minerals that are within the rocks. Okay. This reminds me of what Sabrina, you know, finding the ruby in the granite countertop. Okay. I wonder if the people there at the store even would see that. Okay. Let me catch up with some of the comments here. Okay. Let's see. Okay. The Lord certainly seems to like men and women. Yeah. That's right. That's right. So, and he really looks at us in our true light. We don't even see ourselves in our true light. Okay. Sabrina says about water, I think, you think they'd be equally dense because they are the same thing in this, usually with other substances, the solid into the liquid. That is correct. So that is the question. Why the ice float? Because as you lower the temperature of everything else, it turns into a more dense material, okay, except for water. So that is what I want you to do. Yeah, so the Lord does look at after the youth because they are, and usually they are easily taught. Yeah, we all go through some periods of rebelliousness, trying to see if we can do our own thing. But it is true that generally, you know, the Lord can mold us if we let Him and turn us into precious stones, into gems, under pressure and temperature. Those are the trials that purify our life, that take out the impurities. Imagine if this piece of carbon would remain with the impurities, it would never be able to turn into a diamond. Okay, so that is what happened. Emma says gems take cleaning, polishing, cutting, and refinishing occasionally. All of us gems. We are not always hidden in caves or underground. In our life, we will go through stages of cleaning, cutting, repolishing, but if we allow it, at Judgment Day, we will hopefully be a glorious gemstone ready for all to see. Amanika quotes the scripture, dross to consume and gold to refine. Be willing to go through the fire. That is really the question. The trials, the tests in our lives are actually what help us purify us and turn us into the gemstone that the Lord wants us to be. Okay? So I really believe that, okay? And each one of you, okay? So I would love to, so if we can finish the class, okay? Does anyone have a microphone that would like to pray for us? Sabrina, do you have any one of your siblings? Okay, Haley, you can. Okay, Haley, go ahead.
Our kind and gracious Father in heaven, we're so grateful for the opportunity we've had to come and to learn about minerals, and we're grateful for this earth that Thou hast created for us, and for the beauty that it is, and the opportunity we have to discover and to learn new things about it. And please bless us to continue to discover and to learn more about thy earth, and as we went throughout our day. And please bless us to have a good rest of our night and to keep thy with us. And we say these things humbly in the name of Jesus Christ. Amen.
Amen. Very, very much. Yeah. Thank you very much. I'm going to stop the